Hello, this is Randy White. Today I'd like to share an example with you about de-embedding on the Rohde & Schwarz Rtp oscilloscope. We have a fast pulse source here, two cables. One is a short cable and one is a long cable. This is a 2-meter cable. The way that we can easily compare the effectiveness of de-embedding is to measure the rise time of the short cable and the long cable and compare each before and after de-embedding. As expected, with de-embedding, we expect the rise time to be improved. So let's go and take a closer look. I will add channel 2 here on the bottom. Now I will add a measurement to measure the rise time of both. Okay, now I have approximately 64 picoseconds for the short cable. I expect the long cable to be much slower. Let's see what this measurement turns out to be. We'll stabilize our trigger here. Now we're looking at channel 2, and we'll change the source here for the second measurement to channel 2, and we measure approximately 340 picoseconds average rise time through this 2-meter cable. So let's take a closer look at the de-embedding setup and see how this is improved. So I'm on channel 2. Of all the components that I could add, be it a fixture, adapter, or cable, these are what are available. So I'll choose cable, and I'll go ahead and configure this specific block. I'll choose our 2-meter cable example. Okay, it's always a good idea before you use an S parameter to verify the magnitude response to make sure it matches what you expect. Always know what your expected results will be before you go into using a de-embedding function. Here we have a little bit more than 6 dB out to the full bandwidth of the oscilloscope. That should be okay for this example. So I'll go ahead and turn this on, go back to our setup, turn on real-time de-embedding, which will allow us to use triggering with this setup. Then I enable this, and now the oscilloscope is calculating the filter, and we see a change in the result, which in this case is approximately 57 picoseconds, much faster than our 64 picoseconds that we calculated earlier. So even with de-embedding, we get a better result. Of course, the short cable that we had could also be de-embedded, and I expect that result to match the de-embedded result of the long cable. So now let's go ahead and turn off channel 1, remove our measurement, and show the de-embedding capability for the triggering function. So let's go ahead and go into our trigger menu, and I'd like to trigger on a specific portion of the signal where the ringing happens on the rising edge. So I'll choose the shortest possible width, turn on hysteresis, and now I adjust the trigger level up to the top. And if I zoom in, you can see how accurate this triggering is with about a 50 picosecond wide pulse that we're triggering on. And all this is with the de-embedding, real-time de-embedding triggering capability. So if I go out of the range of the pulse width, then the scope stops triggering. So to summarize, this is a quick example showing improved rise time on a long cable that's de-embedded that gives us an even better result than our short cable, where if both of those cables are de-embedded, I expect both results to match. Taking that one step further, after we de-embedded the cable, now we can apply this de-embedding process in real time towards triggering to help you isolate signals and issues much faster.